Hi students, we are starting second example of exercise 2.3. I will make it with both methods. Old method. Example is x square plus 2x minus 5 is equal to 0. X square plus 2x minus 5 is equal to 0. So first step is transfer the constant term to right hand side. So x square plus 2x is equal to 5. First step is to transfer that constant term to the right hand side. Don't forget changing the sign. Then multiply by half to coefficient of middle term. So middle term coefficient is 2 into half is equal to 1. Square it. So 1 square is equal to 1. Add it to both the sides. So it will be x square plus 2x plus 1 is equal to 5 plus 1. Correct? Now this part is a square of x plus 1 the whole square, and this is let us write first. X square plus 2x plus 1 is equal to 6. X square plus 2x plus 1 is equal to 6. This part is a square of x plus 1 the whole square is equal to root 6 the whole square. 6 is a square of root 6. So, and I have explained in the first term, first example, x square is a square of x, sine of middle term, and 1 is a square of 1. So we have taken, and you know what to do now. Taking square root. Take square root. So it will be x plus 1 is equal to plus minus root 6. The coefficient form will not have any sign, but the number may be plus, may be minus. So square roots may be plus or minus. So after this we will get, taking one time plus value, x plus 1 is equal to plus root 6 and x plus 1 is equal to minus root 6. You have to take one time plus value, one time minus value, positive, negative. So now it is simple. X is equal to minus 1 plus root 6, and this side x is equal to minus 1 minus root 6. So finally roots are minus 1 plus root 6 and minus 1 minus root 6. This example I have done with the old method. Clear? The same example I am going to solve it a new method. Some teachers will use textbook method. It is a new method, but in which they will not transfer that constant term to the right hand side. They will not transfer to the right hand side. They will keep there only. So example is same, new method. X square plus 2x minus 5 is equal to 0. You know it is not a perfect square. So this is plus example, plus sign in the middle term. So use x plus y the whole square is equal to x square plus 2xy plus y square is equal to 0. Identity, we have used identity. So compare first two terms of an identity with examples first two terms. Compare x square plus 2x is equal to x square plus 2xy. These two will get cancelled and we'll get 2x is equal to 2xy. Therefore, x will get cancelled. So it will be y is equal to 2 upon 2. Therefore, y is equal to 1 and y square is equal to 1. I given these details in the first example. So now the term, constant term, the teacher will not take to the right hand side. It is to the left hand side only. We have to add this 1 to the left hand side only. So what to do? X square plus 2x plus 1 minus 5 is equal to 0. In mathematics, you cannot add anything, you cannot subtract anything. You have to balance it. So, what is balancing? Adding and subtracting. One we have added, one we have subtracted. So, one addition and one subtraction will not change the value of equation. So, now you can check this part is a perfect square of x plus 1 the whole square. This part is a square of x plus 1 the whole square. So therefore, x plus 1 the whole square minus 6 is equal to 0. Minus 1 minus 5 minus 6. Correct? 6 is a square of root 6. Therefore, x plus 1 the whole square minus under root 6 the whole square is equal to 0. The equation has come in the form of a square minus b square. A square minus b square. What is a square minus b square identity says? A square minus b square is equal to a plus b, a minus b. A square minus b square is nothing but a plus b, a minus b. So our A is x plus 1, our B is root 6. So the next step will be x plus 1 plus root 6, and another is x plus 1 minus root 6 is equal to 0. So now it is very easy. Equating these two terms with 0, therefore x plus 1 plus root 6 is equal to 0, and x plus 1 minus root 6 is equal to 0. So it will be, transfer the terms, x is equal to minus 1 minus root 6, and this will be x is equal to minus 1 plus root 6. Therefore, roots are minus 1 minus root 6 and minus 1 plus root 6. What is the difference between the previous example and this example, new method? Teacher may not take this term, constant term, to the right hand side. So we have to add and subtract the square term. Add and subtract. In that example, it is easy. Add to both sides. Here we have added and subtracted. Keep in mind. So this is new method. Example, first two terms, plus sign to plus identity. Compare examples first two terms with identities first two terms. You will get this. Cancelling x square, you will get this. Cancelling x and x, you will get this. And lastly, y is equal to 1. Y square is equal to 1. Adding and subtracting. Added, subtracted. The value of equation will not change. Added 1, subtracted 1. This part is a square of x plus 1 the whole square, and this part become minus 1 minus 5 become minus 6. So this part is a square, so remaining is also square. 6 is a square of root 6. 6 is a square of root 6. So that has become a square minus b square type of identity. That has become a square minus b square identity. What is a square minus b square's expansion? It is a plus b, a minus b. Our a is x plus 1, our b is root 6. So a plus b means x plus 1 plus root 6. Our a minus b will be x plus 1 minus root 6. Equate with 0, you will get the roots. By equating with 0, you will get roots. What is difference between last new method and this one? I have kept constant term to the left hand side only, because your teachers may follow the guides, and in guides it has given like this. So hereafter we will use both methods to solve the examples. Whichever you want to write, ask teacher in the school and adopt. But in board, both methods are allowed. In board, both methods are allowed. But doing activities, that is fill in the blanks, if board has given you the fill in the blank type of example, with new method. That time you have to follow the new method only. That time you have to follow new method only. Clear? Nice. So we are starting fourth example of exercise 2.3. Third one is homework. Here you can check the coefficient of first term is 9. Is 9. Coefficient of the first term is 9. In previous examples, it was 1. In previous examples, the coefficient of first term was 1. Here it is 9. Whenever we have to use completing the square method, the coefficient of first term must be 1. Whenever we want to use completing the square method, the coefficient of first term must be 1. So, to get here 1 instead of 9, to get 1, we have divided the equation by 9. Again I am repeating, to use completing the square method, the coefficient of first term must be 1. To use completing the square method, the coefficient of first term must be 1. Here it is 9. So we have to divide the equation by 9 to make the coefficient of first term 1. Okay? Suppose it is 12. So you have to divide by 12. If suppose it is there 4, then you have to divide by 4, like that. But anyhow, the coefficient of first term should be 1. So after dividing by 9, we got the equation y square minus 12 by 9y plus 2 upon 9. Dividing by 9, we got this equation. Here we can cut. 3 3s are 3 4s are. So the final equation is y square minus 4 upon 3y plus 2 upon 9 is equal to 0. 0 upon 9 is 0. So it is 0. Then I have told you, if the middle term sign is negative, you have to use identity negative. The identity must be negative. So in previous example it was x, so we used x minus y. Here it is y, so we have used y minus z the whole square. Identity is used y minus z the whole square. It is y square minus 2yz plus z square. Sorry. Z square. So by using this identity, y we have used 9 negative, the middle term is negative. So y square will get cancelled. Compare the first term of the equation and first term of the identity. Y square is gone. remaining is 2yz is equal to minus 4 upon 3y minus 4 upon 3y. So again y will get cancelled. And we will get minus 2z is equal to minus 4 upon 3. The minus sign from both sides will get cancelled and we will get I have kept it as it is. Minus 2z is equal to minus 4 upon 3. You can cancel it. Minus sign gone. So z is equal to 2 will come this side. Z is equal to 4 upon 3 into 2. 4 upon 3 into 2. What we have done? Minus 2z is equal to minus 4 upon 3. So minus sign gone. Z is equal to, this 2 has come to the denominator. And the new term 4 upon 3 into 2 has formed. 2 1s are 2, 4s are 2. So final answer Z is equal to 2 upon 3. Z is equal to 2 upon 3. So we need Z square. So square of 2 upon 3 is Z square 4 upon 9. We got the term. Now in new method we have to add and subtract. So y square minus 4 upon 3 plus 4 upon 9 minus 4 upon 9 plus 2 upon 9. This 2 upon 9. We have added this term, added and subtracted this term in this equation. So added and subtracted. This is the thing we got. After that you can check. Up to this it is a perfect square. Y square is a square of y. Y square is a square of y. And 4 upon 9 is a square of 2 upon 3. Y square is a square of y. And 4 upon 9 is a square of 2 upon 3. So this compact thing we got. And the sign of minus came from middle term. Sign of minus has come from the middle term. I have taught you in the previous examples. Square root of y square y. Square root of 4 upon 9 is 2 upon 3. And the sign of middle term. You got it? So this become y minus 2 upon 3 the whole square. And the remaining part. And the remaining part is this one. Minus common, and in the bracket it become 4 upon 9 plus will become minus 2 upon 9. So 4 denominators are same. So 4 minus 2 is 2. 2 upon 9 is remaining there. So we have to make it now a square minus b square type of identity. A square minus b square identity. So it will be y minus 2 upon 3 the whole square into bracket root 2 upon 3 the whole square is equal to 0. 2 is a square of root 2. 2 is a square of root 2. And 9 is a square of 3. So we got a square minus b square. A square minus b square. Now it's very easy. since a square minus b square is equal to a plus b and a minus b, our a is y minus 2 upon 3 and b is root 2 upon 3. Our a is y minus 2 upon 3 and our b is root 2 upon 3. So this will become first bracket y minus 2 upon 3 plus root 2 upon 3, and in the second bracket y minus 2 upon 3 minus root 2 upon 3 is equal to 0. Applying the identity, we got a plus b, a minus b. Our a is this part, b is this part. Our a is this part, b is this part. A plus b, a minus b. Now equating with zeros, first y minus 2 upon 3 plus root 2 upon 3 is equal to 0. And next is y minus 2 upon 3 minus root 2 upon 3 is equal to 0. Change the sides of the constant terms. It will be y is equal to 2 upon 3 minus root 2 upon 3. This become plus, this become minus. And y is equal to 2 upon 3 plus root 2 upon 3. See, this minus become plus, this minus become plus. This minus become plus, this plus become minus. So the final answer is y is equal to 2 minus root 2 upon 3 and y is equal to 2 plus 2 root 2 upon 3. When you solve these examples 2-3 times, that time you will get clear these all concepts. So the roots are 2 minus root 2 upon 3 and 2 plus root 2 upon 3. This is a different example because of the coefficient of first term was not 1. So first we made it 1 by dividing 9. Whichever number is there, you have to divide by that number. So it is 9, so we divided by 9. We got this equation. Coefficient is 1 now. And after that, comparing with negative identity, since the middle term sign is negative. The middle term sign is negative. So previously we were using x minus y the whole square. It is y. So we have taken y minus z the whole square. Comparing with it, we got minus 2yz equal to minus 4 upon 3y. Y will get cancelled. Negative sign will get cancelled. We got minus 2z equal to minus 4 upon 3. Negative sign will get cancelled and that 2 will come in the denominator. We got z is equal to 2 upon 3 and z square is equal to 4 upon 9. After that, as a new method, we have added and subtracted the square term, and after that we have taken the identity a square minus b square. It is a plus b, a minus b. Our a is this part, our b is this part. So a plus b, a minus b. Equating with zeros, we get Keep head cool and think everything is easy. Keep head cool and think and solve. Everything is easy. Practice 2-3 times, you will get idea what to do and how to solve. Okay? Students, we are starting next example of same 2.3. It is fifth example. Again you can check the coefficient of first term is not 1, it is 2. In the previous example it was 9, so we had divided by 9. Here it is 2, we have to divide by 2. So it's very easy. Divide by 2 means to each term we have to divide by 2. Cut and you will get y square plus 9 upon 2y is plus 5 is equal to 0. Why we divided by 2? To get the coefficient of first term 1. Correct? After that, this is the plus identity example. Reason, the middle term sign is plus. So we have taken, it is in the y, so it has taken as a y plus z the whole square. Y plus z the whole square means y square plus 2yz plus z square is equal to 0. This identity we are using. So comparing examples first two terms with identities first two terms. Comparing examples first two terms with identities first two terms. We got 2yz, y square cancelled. So 2yz is equal to 9 upon 2y. Again y will get cancelled. And we get 2z is equal to 9 upon 2. This 2 will come in the denominator and the number will become z is equal to 9 upon 4. The number will be z is equal to 9 upon 4. So z square, we require z square. So z square means 81 upon 16. 81 upon 16. Now, according to new method, we have to add and subtract same number in the LHS. Same number in the LHS. So we have added here y square plus 9 upon 2y, this part, plus 81 upon 16 minus 81 upon 16. Reason, in the equation you have to follow the rules of mathematics. So adding, subtracting the same number does not change the value of the equation. So we have made it, and this one. This part is a perfect square. In each example I am explaining this. This part is a perfect square. So it is y square, square root is y. 81 upon 16 square root is 9 upon 4. And the sign of middle term. The sign of middle term. So y plus 9 by 4 the whole square. This part will become y plus 9 by 4 the whole square. Remaining part of numbers, take out the minus sign common. Take out the minus sign common. In the bracket you will get 81 upon 16 minus 5 upon 1. Taking out minus sign common, in the bracket we got 81 upon 16 minus 5 upon 1. Minus 5 upon 1. So this part will remain same, and the remaining part minus common, 8 cross multiply, 81 minus 16 5 is 80, after cross multiplication, 81 ones are 81, 16 5s are 80 upon 16, cross multiplication. So this part will remain again same and this part become 1 upon 16. 1 upon 16. And you can check this has become perfect square. Sorry, it is plus. It is, I will change and start. We were in the middle of the example. We got y plus 9 upon 4 minus 1 upon 16 by cross multiplication. So, to make it in the form of a square minus b square, square root of 1 is 1 and square root of 16 is 4. So 1 upon 4 the whole square. Now it has become a square minus b square the whole square. A square minus b square the whole square. The identity expansion a square minus b square is a plus b, a minus b. The identity is a square minus b square and its expansion is a plus b, a minus b. So it will be a part is y plus 9 by 4, a part is y plus 9 by 4 and b part is 1 by 4. So a plus b, a minus b. So after that it is easy equating with zeros. We got this one. So y plus 9 by 4 plus 1 upon 4 and y plus 9 by 4 minus 1 by 4. So this is the answer. Y is equal to sign changing minus 9 by 4 and minus 1 by 4. It has become y is equal to minus 9 minus 1 upon 4. It is minus 10 upon 4 and it is nothing but minus 5 upon 2. Minus 5 upon 2. First root. Second root. Y is equal to minus 9 by 4 plus 1 upon 4. Sign changed. So after changing this, we got minus 8 upon 4 and the final answer is y is equal to minus 2. So our roots are, equation's roots are minus 5 upon 2 and minus 2. I am again requesting you to practice these examples more and more. You will get mastery on these examples. This is fifth example of 2.3. Students, we are starting sixth example of exercise 2.3. This is 5x square is equal to 4x plus 7. It is not in the standard form, so we have to make it first in the standard form. So we have transferred these two terms to the left hand side. So 5x square minus 4x minus 7. Now it is in the standard form. But question is whether the first term coefficient is 1. No, it is not. So it is 5x square. We have to divide the equation by 5. To make the coefficient of first term 1, we have to divide the equation by 5. After dividing by 5, we got x square minus 4 by 5 x minus 7 upon 5. Now, the sign of middle term is negative, so we have to use the negative identity. So it is x, so x minus y the whole square. What is the value of x minus y the whole square? It is x square minus 2xy plus y square is equal to 0. Compare first two terms of our example with an identity's first two terms. So first two terms of our example with first two terms of an identity. So identity, our terms. X square will get cancelled. X square will get cancelled, and we got minus 2xy is equal to minus 4 by 5x. Sign will remain, minus minus will get cancelled. We got 2y is equal to 4 upon 5. We got 2y is equal to 4 upon 5. So we got 2y is equal to 4 upon 5. 2y is equal to 4 upon 5. Minus minus sign got cancelled. Now this 2 will come in the denominator. So y is equal to 4 upon 5 into 2. So y is equal to 4 upon 10. After cutting, we got y is equal to 2 upon 5. 2 2s are 4, 2 5s are 10. So y is 2 upon 5. So y square will be 4 upon 25. 4 upon 25. So we got the value of y square. Therefore, y square is equal to 4 upon 25. Now you know the procedure. You have to add and subtract that square term in this part of equation. The last number, that is constant term, will remain as it is. So compare this part. It is a perfect square. It is a x square means square of x, sign of middle term, and 4 upon 25 is a square of 2 upon 5 the whole square. Minus sign common, and in the bracket we got 4 upon 25 plus 7 upon 5. This step is very important. In every example, this step is very important. After adding the square term and subtracting the square term, first three terms will give us a perfect square. After that, you have to take common things correctly. So we have taken minus sign common, and in the bracket we got 4 upon 25 plus 7 upon 5. This step is very important. Be careful here, and hereafter it's easy now. Therefore, x minus 2 upon 5 the whole square minus in the bracket cross multiply 20 plus 175 upon 125 is equal to 0. So hereafter the procedure is same. This is the perfect square we have taken, and this is after cross multiplication we got these two terms. 5 4s are 20, 25 7s are 175, 25 5s are 125. So the next step is x minus 2 upon 5 the whole square will remain as it is, and this will become 195 upon 125. it is cutting by 5, we get 39 upon 25. Therefore, x minus 2 upon 5 the whole square minus 39 upon 25 the whole square is equal to 0. Now you can check, it is a square minus b square the whole square. A square minus b square. The identity is a square minus b square is equal to a plus b, a minus b. Our a part is x minus 2 upon 5 and b part is 39 upon 25. So solving it, x minus 2 upon 5, x minus 2 upon 5 plus 39 upon 25. Correct? Into another bracket, it is x minus 2 upon 5 minus 39 upon 25. It is a plus b, a minus b. A plus b, a minus b. Let us have the revision. We have added this square part in the equation. After that, adding and subtracting, we got the square part, perfect square part, and the remaining number part. This is perfect square part we have kept as it is, and after cross multiplication we got this 5 4s are 20 and 25 7s are 175 upon 125. So after that we got 195 upon 125. After cutting we got the small numbers 39 upon 25. To make it in the form of a square minus b square, a square minus b square, the square of the square root of 39 is root 39. The square root of 39 is root 39 and square root of this 25 is 5. Square root of this 25 is 5. So you have to keep in mind in such examples, these things are very important in the calculation. In the exam, in the hurriedness, you will make the mistakes. So, to make it perfect square, a square minus b square, we have taken square root of 39 is root 39 and square root of 5 is 25 is 5. So, we have made it. After that, equating with zeros, x minus 2 upon 5 plus root 39 upon 5 is equal to 0, or x minus 2 upon 5 minus root 39 upon 5 is equal to 0. Therefore, x is equal to 2 upon 5 minus root 39 upon 5. This side, x is equal to 2 upon 5 plus root 39 upon 5. So final answer is 2 minus root 39 upon 5 and x is equal to 2 plus root 39 upon 5. So roots are 2 minus root 39 upon 5 and 2 plus root 39 upon 5. These are the answers. You can check at your in your textbooks. It's very easy. So you can check in your textbook. The answer is this one. So I am requesting you in such examples, you must be very careful and keep head cool. If there is any deviation in the thinking, your whole hard work will go in vain, time will be wasted, and you will not score the marks. This finishes our completing the square method. This finishes our completing the square method. Once again I am explaining. Given equation was not in the form of standard form for the completing the square method. Divided by 5, we got this one. Equating with the identities, we got y square is equal to 4 upon 25. We have added it. First 3 terms give us perfect square. We have taken the compact form. Remaining number part. This step is very important while taking out the common. So minus sign is taken out. In the inside it will be 4 upon 25 plus 7 upon 5. After that cross multiplication, you got this number. After cutting, you got this number 39 upon 25. So square root of 39 is square root of 39 is under root 39. Square root of 39 is under root of 39, means this is not a perfect square, so under root 39, and square root of 25 is 5. You cannot take square root of 39, so we have kept it under the root sign, and 25 gives us the root 5, and after that a square minus b square is equal to a plus b, a minus b. Equating with zeros, calmly and quietly sign changing, and we got the answer. Keep head cool while solving such examples. Thank you. This finishes our completing the square method. Next is formula method. Next lecture will contain formula method of solving quadratic equations. Thank you.